So for question 12, you seem to know how to do the first part quite okay. You are missing some stuff for part A. Part B, you seem very stuck at it. And then part C, yeah, because you didn't attempt part B, you can't attempt part C. Okay, so we look at the question again. Okay, the mineral phosphide Ca3PO42 exists as a phosphate rock in its impure form. Okay, impure form. Elemental phosphorus can be prepared from the phosphate rock. So this phosphate rock, it will have been Ca3 PO4 2. Okay, so because this substance is inside the phosphate rock and this phosphate rock is not 100% Ca3 PO4 2. So this means it's not 100% Ca3 PO4 2. Okay, and then they say it's through reduction using carbon and in the presence of sand, which is SiO2. Okay, the reduction of phosphorite produces solid A and carbon monoxide. So over here you can identify clearly what are the reactants and products over here. Okay, so the reactants over here, you can see that it's phosphate rock and using carbon and SiO2. Okay, so if I were to write down what are the reactants over here, with Ca3 PO4 2, okay, SiO2 and carbon. Okay, so all of this will have been in solid state. Right, then now if we look at what are the products, okay, when you see the word producers, it probably means, okay, it will be solid A, carbon monoxide is in gaseous state, and then you see over here, elemental phosphorus can be prepared. So the word prepare is also another important word to take note when you are trying to identify what is the product over here. Okay, so elemental phosphorus, you can either write it as P or P4. I would recommend you to write it as P4 if they did not state, because this is actually how phosphorus exists at room temperature and pressure. So it exists as a polyatomic molecule, just like other polyatomic molecules like Cl2, I2, Br2. For elemental sulfur, it will have been S8. Okay, you can look at the balancing chemical equation worksheet and notes to know what are the elements and the molecules to take note which are polyatomic, and they did not specify in the periodic table. Okay, so over here you see A contains only these elements and it has a composition by mass of these elements. You notice over here that oxygen is not given, so you are expected to calculate for oxygen. Okay, relative molecular mass of A is 116.2, and then you're told to determine the empirical and the molecular formula of solid A. So notice that you have to determine two formulas over here, so not just empirical formula. Okay, so whenever you are to determine what is the empirical formula, you are told to do this table up. Okay, so this table, something to take note is that for the headers of each row, you need to be accurate in terms of what you write. So percentage by mass, not percentage of mass. Okay, so percentage by mass, and then the next row, actually there should be a relative atomic mass row also, where you write, okay, what is the relative atomic mass of each element. But honestly, if you didn't write this down, it should be okay. Alright, okay, so this additional row, and for number of moles, it's not amount of moles, okay, it's number of moles. Okay, you either write amount, okay, you either write it as amount of substance and then you slash mole, because this is the unit of measurement, this is the physical quantity. So you always have to present it in this way. Okay, if not, you can also write it as number of moles n. Okay, the reason why I say you need to write this n word is because for the next part you did mention about dividing it by the smallest n. Okay, so what this n refers to, you need to specify what it refers to by putting it over here. Okay, and then it's not simplest ratio yet, it's mole ratio, because from mole ratio to simplest ratio, there's actually one more step that you need to take. If let's say the mole ratio is given in terms of a fraction such as 1.5, or let's say 1.20, or let's say 0.25, because as you can see here, these, alright, okay, not 0.25, maybe 1.25. Okay, so as you can see over here, these are actually not close to any whole number, is actually a fraction. So in that case, you need to multiply by the denominator in order to convert it to the simplest ratio. So that's why you need to have two separate rows, one for mole ratio and one for simplest ratio. Okay, can? So each of the numbers over here, one thing to take note is that your intermediate workings always have intermediate workings. Okay, all the intermediate workings should be to 4SF and not rounded up. Okay, so if let's say this one is let's say take for instance the amount of calcium atoms in solid A. Okay, 34.2 divided by 40.1. The calculator value it will have shown you is 0.85286788304. This is the one that you need to use in subsequent calculations. Right, so over here you see that the answer that I have written down in red. Okay, the answer I written down in red is 4SF, but I didn't round this 8 up. Okay, so make sure you don't round up the intermediate workings, just leave it as 4SF untruncated, not rounded off. Okay, so for the blue working over here that I have written down, saying that this is a calculator value, right? You need to use them in subsequent calculations. Okay, so what I mean by that is that if example I don't use that exact number, so let's say I just take 0.8718 divided by 0.8528, okay, I wouldn't have gotten this value. Okay, I wouldn't have gotten 1.022. Okay, if I just use this number and this number, plug these numbers into the calculator, it will have given me 1.05570356. Okay, which is completely different from the final answer over here, where I use the calculator value. Okay, so this one will have been 0.85286780304, and then 0.8718, if you calculate what is the calculator value for this, it will be 0.871886121. So just keep in mind you use these in the calculator to get 1.022. Okay, if you use the red one, 0.8718 and 0.8528, you will have gotten this value instead. So just take note of that. Okay, maybe I just change this one. Okay, so that it's much easier for you to see. Okay, yeah, so it's much easier for you to see the difference. Okay, so mole ratio also leave it to 4SF, and then you can get the final answer, which is the empirical formula. I wouldn't use the word equal sign, you can just say empirical formula is, okay, cause equal you usually use it when you're talking about numbers. Okay, so try not to make this kind of small mistakes, if not you might get penalized. Okay, for the second part, yeah, once you identify the reactants and products, you're able to deduce for part B. oh yeah, I forgot one more thing. Okay, so part A, right? Your molecular formula, you still have to determine the molecular formula. And there's one more extra step you need to take. Okay? Because sometimes empirical formula may not necessarily equal to molecular formula. I could have a molecular formula which is this. And it will still have been the empirical formula. Okay? So just take note. So what you want to do over here, this working. So let the molecular formula of solid A be CaSiO3N. Okay. Afterwards, you need to calculate for what is N. You want to calculate for what is N, you take the MR of the solid A divided by the relative mass of from the empirical formula. Which is CaSiO3. Okay, so if we look at what's the relative molecular mass, 116.2, 116.2 divided by the relative mass of the empirical formula, which is 40.1 plus 28.1 plus 316. Okay, that will have given me 116.2 also, so N will have been 1. Okay, so and then you can just conclude over here, molecular formula is CaSiO3. Okay, notice N I represented to the nearest whole number because it can only be an integer. Okay, right, and that's it for part A. Okay, now let's move on to part B. So for part B, you're given the reactants, okay, as well as the products, okay. And now, what you normally try to do is you want to balance the atoms which do not appear more than once in the reactants or the products. So usually this is not oxygen or hydrogen. Okay, so maybe let's say I look at it across the board. Maybe I can try to balance calcium first. See, calcium is 3 atoms on the left hand side. On the right hand side, I can balance it out with 3. Okay, maybe the next one I can choose is either either phosphorus, carbon, or silicon. Okay, because on the right hand side, I know that silicon is also affected because I put the 3 next to this CaSiO3. So that's why I need to also balance out the silicon atoms. On the left hand side, through putting 3 next to sand, right? Okay, afterwards, you are given the option, okay, either carbon or phosphorus. Okay, so carbon or phosphorus. Phosphorus on the left hand side is P2, and on the right hand side I noticed there's P4. Okay, so you can put a half over here, right, just to show that it's balanced first. Of course you can't put fraction at the final answer, so we need to multiply it later on. Okay, we notice carbon on left hand side and right hand side is 1:1, so it's okay, but for oxygen it's not really the case. Okay, there's 8 oxygen over here, 6 oxygen. Okay, there's 1, and then there's 9, so this is 10. Okay, so I do not want to touch those ones that I have balanced out already. So what I want to do is that I want to write this number here first. So if there's 14 on the left, 10 on the right, Okay, I need to know what is this number over here. So 14 minus 9 would have been 5. This one I put 5. Okay, if I put 5, yeah, oxygen would have been balanced out. And then last but not least, because carbon is affected, so that's why I put 5 over here. And last but not least, because okay, you can put fractions in your final answer, but I try not to recommend that. It's always safe to put it into whole numbers. So I will multiply everything by 2. Okay. Yeah, so just check one more time. Okay, for P 8 times, okay, so 10 C's SI, alright, 8 times 2, 16, 16 plus 12 is 28, so 28 on this side. Okay, 10 plus 18 is 28, so everything is balanced out, so that's just to double check everything. Okay, so notice the atoms that I balance out, the last is oxygen, because you see oxygen appear more than once on both sides. Okay, so it appears here, it appears here, so more than once in more than 2 reactants, and in more than 2 product it contains oxygen, so oxygen balances last. Okay. Okay, so last but not least, let's look at part C. Okay, for part C, 5.3 grams of phosphorus is produced from 30 grams of phosphate rock, which we have talked about is impure. Okay, so this is impure, right? And then we need to calculate for the percentage purity. So notice for this part, okay, we want to go back to our flow chart over here. Okay, so we done our balance equation. Limiting reagent, this one you also want to take note of this, because whenever you're given just the mass of the product, okay, once you're given the mass of the product, I think you are preferred to use the mass of the product rather than any other numbers that are given, because the limiting reagent determines the mass of the product produced. Okay, so this one. Okay, the limiting reagent will determine the mass of the product produced. Okay, so and then you just apply the relevant formulas. You're given mass, so the fact that you're given mass, you are to apply molar mass to reach the number of moles. Okay, so and then last but not least, because they told you to calculate for percentage yield, you need to calculate for percentage yield, right? Okay, so first off, you're given the mass 5.3 grams of phosphorus. Now I need to calculate for the number of moles phosphorus. Okay, 5.3 divided by P4, right? P will have been a relative atomic mass. Right, let me go check. 31. Okay, so 4 times 31.0, this one will have been 5.3 divided by 431, 0.04274. And then last but not least, you just need to go check. Okay, so it is a 1:2 ratio, so you need to multiply it by 2. CA3PO42 is to P4 is a 1:2 ratio, so multiply this by 2, 0.08548. Okay, and then you just need to calculate for the mass. Take this, multiply by the molar mass, right? So 340.1 plus 2, okay, 31.0 plus 4, 16.0. Okay, So this will have been 26.52 grams. And then we're going to calculate for the percentage purity. Okay. Been 26.52 divided by 30.0 times 100%. That will have given you 88.4% to 3SF. Right. Okay. Let me go double check, because we have used P4 as the right, so it doesn't seem to affect. So whether you use P or P4 as your relative, as your molecular, as the chemical formula for elemental phosphorus, it seems to be okay because you still get the same answer as 88.4%.